So let's mark these. First of all, motion with changing velocities. Mix and match the following graphs with the descriptions below. Okay. Which one of these changed speed, then stopped for a while, then continued on at the second speed? Which one of those graphs is that? Yeah. C? Is that a phone I heard? Did I hear a little ding there from the back row there? Don't think so. C. Which then changed to a lesser second speed? A. Which one started off going and then stopped? B. Match the following graphs. Okay, now we're looking at Kerbey graphs. Which graph represents an object whose speed decreased gradually? I think B, yeah? Because the slope is the speed, and it's getting less steep. Increased gradually. I think that one is speeding up because the slope is slowly increasing. Increased gradually, then decreased gradually. I think that would be C. Match the following graphs with the descriptions below, 1 mark each. The object's speed decreased to 0, then increased again as the object returned. Okay, the object's speed decreased to 0, then increased, and the object returned. Oh, you know what? I think isn't that this one? Slowing down, hit 0 for a split second, right about there. And then we also, what was our final displacement? How high are we at the very, very end? 0. That must mean that we went back to our original starting point. Cool. The object traveled at a constant speed, then stopped for a while, then returned to its starting point at a constant speed. I think that's A. The object traveled at a constant speed, then moved back and forth twice, always at a constant speed. So let's see. Going forwards, going backwards, going forwards, going backwards, going forward. Yeah, that works. B. Is that okay there? You can give yourself a little score out of 9 at the top. Right there. And if you could pass that inwards, please. And we gave out a second quiz. It looked an awful lot like acceleration quiz number 1, I think it was called. Yes? So get out this one, please. This is one I could have given out a few days ago. This is actually one that only uses average acceleration. Really, it only uses this equation here, because this equation here comes out of that equation there. Because change anything is final minus initial. This one is actually acceleration is v final minus v initial over t, which actually is the same as that one. If you rewrite it and get the A by itself. First of all, what is acceleration? Can you give me a definition of acceleration? Anybody? There's a 3-word definition that's a pretty easy one. Yeah. Sorry? I'll take that, but there's a better definition because that would not include going backwards. Yeah. Best definition, acceleration is a change in velocity. That would get you 1 mark. Anybody else write something else that they want to try out? Call it out, and I'll say yay or nay. Really? Everybody wrote change in velocity? Yeah.
Slope of velocity time graph.
I'll take that, but sure.
Acceleration is the speed traveled in meters per second.
I'm going to actually say no. It's not the speed traveled. It's the change in speed. Speed is meters per second. So I'm going to be fussy and say a half mark. Anyone else? Is acceleration a vector?
Yeah.
Yep. Yes. 1 mark for saying yes. Let's use good grammar on my answer key. Yes, it is. Is negative acceleration always an indication of slowing down? And convince me. What'd you say here? Yeah.
No.
Convince me. But by the way, I can think of an answer that is correct for the word yes. That could be correct depending on how I explain it, and I can think of a way to no would be correct. So convince me. Yeah, go ahead.
No, it can also mean that you're going faster in the left or backward direction.
Okay, I'll take that completely. So AJ said no. You could be speeding up going backwards. I'll take that. Yeah. What if you just said going backwards? You answered the second half. I'll give you 2 marks, but I think there's 2 parts to that question there, yes?
No, it could also mean.
Oh, you said no, comma?
Yeah.
That's fine, sure. Anybody say yes? Because there's a way to answer this with the word yes. Okay. It's a convoluted explanation, then I'll leave it alone. So we said no, you could speed up going backwards. Number 3 says, say whether you're speeding up or slowing down for each of the following situations. Okay. Velocity is positive, acceleration is negative. Speeding up or slowing down? Anyone? If your velocity is positive and your acceleration is... Did I say negative? Sorry, A. Velocity is positive, acceleration is positive. Speeding up or slowing down? Speeding up. You know what? Up. Velocity is positive, acceleration is negative. Down. Slowing down. Velocity is negative and acceleration is positive. Sorry? Convince me. By the way, this question has 2 answers, and I'll take both if you convince me correctly. So I'll accept that if you convince me. Give me an example. Give me a situation.
You could be going in reverse, backwards.
So that would be the velocity is negative, and
You could be speeding up going backwards.
that would be a negative acceleration, wouldn't it be? So I may still take your answer, but not with that example. Anyone, velocity is negative, acceleration is positive. Speeding up or slowing down? Sorry?
Slowing down.
Slowing down, convince me.
Because if you're, say, negative 5 meters per second, and your acceleration is positive, then you're getting slower.
So he's saying if you were going backwards, a positive acceleration would mean you were starting to accelerate going forwards. So first, going backwards, you'd slow down, come and start going forwards?
Yeah.
Okay, I'll take that. There is a way to explain this as speeding up. And if you said speeding up and you want to try and convince me, go ahead. Yeah.
Speeding up in the positive direction.
Ah. So are you saying that, for example, if you were initially going negative 5 meters per second, and then later on, because your acceleration was in the positive direction, you were going negative 2 meters per second, that negative 2 is a bigger number than negative 5, because it is on the number line. Negative 2 is bigger than negative 5, more positive than negative 5, and therefore speeding. I'll take that. There you go. I'll take that. There's a good explanation. D, velocity is negative and acceleration is negative. What'd you say? Speeding up? Convince me. Who's calling that? Yeah, convince me. Go for it, John. What you got? Yep. Okay. I'll take that. Now, Michael might argue that because you're getting more negative, that technically means the numbers are getting smaller on the number line in math. And I will take, so I will, if you wrote slowing down and you had that explanation, I'll take that too. I really, I like this question. It's a good thinking question, Connor. It's not a great, what's the correct answer question. So I don't like this question that way, and that on a test or a quiz, questions should have a clear answer, but it is good for discussion for us to talk about. What do we mean by speeding up and slowing down? Number 4, what's the slope of velocity versus time graph represent? Acceleration. All right. Number 5, a car's velocity increases from 5 to 25 in a time interval of 5 seconds. What's the average acceleration? Acceleration is v final minus v initial over t. It's going to be 25 minus 5 all over 5. It's going to be 20 over 5. Do you get 4.0 meters per second squared? Is that right? 1 mark. A bus is moving at 30.0 meters per second. The driver steps on the brakes and the bus stops in 6 seconds. What's the average acceleration? I'm expecting a negative answer here, I think, Tanisha, because we are slowing down, I think. Acceleration is going to be v final minus v initial all over t. What's my final velocity here? Yeah, stopped. Minus initial is 30 all over 6, and you get negative 5.0 meters per second squared. Yeah? Number 7, turning the page, or next page over. If a car with velocity 3 meters per second at time 0 accelerates at 5 meters per second squared for 3.5 seconds, what's its velocity at time? Oh, you know what? I think what it's really saying is what's v final, which I'm pretty sure is v initial plus at. I'm pretty sure it's 3 plus 5 times 3.5. Can I do this in my head? 5 times 3 is 15. 5 times 0.5 is 2.5. So 17.5 plus 20.5? Yeah? Woohoo! Pardon me? If you said 21, I would take that because technically I should go to 2 sig figs. Sure. How long will it take you to go from 2 meters to 10 meters per second if you're accelerating? Oh, they want t. I'm pretty sure t equals v final minus v initial over a. This one was worth 2 marks. If you wrote that, that would get you 1 mark. Then v final 10 minus v initial 2 all over a. 3.5. You notice I'm kind of deficking on the fly. I'm listing my data right into the equation. I really shouldn't do this on a quiz. In your homework, I don't mind if you try getting that good, Callum. Certainly on a test, I would list everything, but we're in a bit of a rush. 10 minus 2 is 8 over 3.5. Can I do this one in my head? 2 point, I don't know, 1 something. No, a little more than that. 2.2857, 2.3 seconds. And that would also get you 1 mark for the answer. What must your initial velocity be? Oh, now they want v initial, which I think v initial is v final minus at, because would I not minus the at over to the other side? I think. What must your initial velocity be if you accelerate at 3.2 meters per second squared for time 3? Okay, let's see. Final velocity is 20 minus a 3.2 times time 3.3. I'm going to get 20 minus 3.2 times 3.3. And you get 9.44? Yeah. 9.4 meters per second. Once again, I would normally give you 1 mark for that and then 1 mark for the answer, since it says it's worth 2 marks. You can give yourself a score at the top of this quiz out of 16. However, I'm not going to collect this quiz. And the reason I'm not going to collect this quiz is I'm not happy with question number 3. It's too vaguely worded. It's too easy to get tripped up. It's not very, very clear. So this is only for your own personal gratification. However, probably later on today, you'll be getting another take-home quiz. Also, your test will be in 1 week on Tuesday, November 27th. Means we're pretty near done. Okay? So you can hang on to that one. So relative velocity. As an example, just to jog your memory, just to review, you are traveling down the freeway at 100 kilometers per hour when a white Escort hurtles by you at 140 kilometers per hour. Well, you don't see the Escort to be moving away at 140 kilometers per hour. You see it moving away from you at 40 kilometers per hour because you're moving in the same direction. You see the relative velocity of it. The relative velocity of any object, moving object, depends on your point of view or your frame of reference. Sure, you see the car moving away forwards at 40 kilometers per hour, but the other driver, if he looks in his rearview mirror, to him, you're driving backwards at 40 kilometers an hour away from him, with your front end facing him, but slowly receding in the distance. So that must mean you're traveling backwards relative to him. Yes? As an example, a zebra is running for its life from a cheetah. The zebra is running at 50 kilometers per hour. The cheetah is going at 90 kilometers per hour. What velocity does the zebra see the cheetah as having, and vice versa? So from the zebra's point of view, what would it see? It would see the relative velocity as 40 kilometers, oh, I wanted red, Mr. Duke, and a better line. 40 kilometers per hour forwards, because the cheetah, when it looks behind it, sees the zebra, when it looks behind it, sees the cheetah facing him and getting closer as though he's coming towards me. What does the cheetah see? Well, the cheetah sees the back of the zebra slowly coming towards him. The cheetah, it appears, sees the zebra traveling backwards towards him relative to the cheetah at negative 40 kilometers per hour, or 40 kilometers per hour backwards. So, as a question, if the zebra starts out 90 meters ahead, how long will it take until the cheetah gets supper time? Okay. What's this question asking me to find? Time? Let's write down t equals question mark. Nathan, what else has this question given me? I think so. We're going to assume, Nathan, that there is no acceleration for these relative velocity questions, and that will be the case if I give you two different velocities in the same question for two different objects. Assume they're traveling at a constant speed. I need one more thing. Well, what I really need is the relative velocity. And as far as the zebra is concerned, the cheetah is traveling at 40 kilometers per hour. You know what? We got a bit of a problem here because this is kilometers per hour and this is meters. Let's do our conversion. Let's change this 40 kilometers per hour to meters per second. How do I go from kilometers per hour to meters per second? It's something to do with a 3.6. Divide by 3.6? Okay. 40 divided by 3.6. 11.111. I'll go 11.11. So what equation could I use to find time here that has d and a, although a is 0, so whatever the a is part of will cancel, woohoo, and v in it? I think I'd start out with this bad boy. And it's technically vi, but then I would say, hey, wait a minute, Matt, a is 0, so the vi is v final. In fact, it's the Science 10 equation that you had all those years ago. I think time is going to be distance divided by velocity. Yo. What's a? So why did I scratch out the half, the a and the b? What's 0 times a half times t squared? Still 0, right? The displacement is 90. Velocity is 11.11. 90 divided by that there. Oh, 8.1 seconds till lunchtime. That means if there's safety or shelter less than 8 seconds away, the zebra is a happy camper. If not, no luck. Or maybe it could be because cheetahs can only carry that speed on for about 20 or 30 seconds at a time. Maybe if this question had been 40 seconds as an answer, the zebra would say, ha, I can run longer. I'm slower, but I can run longer. I got more endurance than you. As long as I get enough of a head start, I can tire you out. It's the great circle of life, Simba. The great circle of life. Example 2 says, state the relative speed in each case. We did this last class. That was part of last day's notes. And then we did this train question last class. That was part of last day's notes. So now we get to the homework that was supposed to be part of last day's notes and for some reason didn't show up on last day's notes. Homework, I think you can try number 1. I think you can try number 2. A couple of relative velocity questions. And then if you look at the next page over, we have some relative velocity. So number 1, absolutely. 2, absolutely. 3 is nerdily cool. Now 3, I would do everything in meters per second. So I would change this kilometers per hour to meters per second, get an answer in meters per second, and then go back to kilometers per hour. 3 is tricky. 3 is tricky. Skip 4, and then you can try number 5. Okay. And there are scrambled answers there. So that's part 1 of the homework. And then I have a couple of quizzes, another take-home quiz, and I'm going to give you a great big review assignment. So I said test was going to be Tuesday. I think your test next Thursday, which is going to be November, I think the 29th or something like that, give or take. Okay. So I've given you 2 handouts. One is a little take-home quiz, and then one is a little review of acceleration and slope. Where's that one, Mr. Dewick, on here? Have you got it here? Yes, I do. So I gave you this one. Starting to do some review. So I've given you 2 lines. This is 5,91.5 and 5,71.5. See if you can figure out the equation for line B. You could using y equals mx plus b for line A and for line B, and then get the acceleration. So now we're going back to our graphing approach. Good review as we get closer to the test. Another velocity time graph, and on the back another velocity time graph. All sorts of stuff. There are scrambled answers there. So your homework, step 1, see if you can handle the relative velocity stuff. 5 questions, 6 questions, 1, 2, 3, 4, 5, 6 questions, because I skipped 1. Then handle the take-home quiz, because that's absolutely due, so acceleration quiz number 2. And then try the, where was it, Mr. Dewick? Acceleration and slope handout. Next class, I'll have one more take-home quiz for you, the final take-home quiz, and I'll have a big unit review. We'll go over that take-home quiz on Tuesday of next week. Your test will be Thursday. Probably Tuesday of next week, we'll do a shuffle, and we'll start our next unit a little bit as well. Any questions at all? Okay. Nothing spectacular here.